In this video, we are going to learn how to graph an absolute value function with translations. But first we'll start with the simple absolute value function, which is just y is equal to absolute value of x. Now when I plug negative 3 into the absolute value, I get a positive 3. Negative 2 gives me a positive 2, then 1, then 0, then 1, then 2, then 3, when plugging all of those into the absolute value function. Basically just making everything positive if it wasn't already. Now when I go to graph these points on the grid, I'll have negative 3, 3, negative 2, 2. That's me just following these points in the table. Negative 1, 1, 0, 0, 1, 1, 2, 2, and 3, 3. And you're kind of seeing the shape of like a V, which is the general shape of an absolute linear function. I'm going to take my straight edge, connect the dots. And it creates an absolute linear function, absolute value linear function. Now there's a few key characteristics. First being that there is a vertex to this graph, which happens to be at 0, 0. And also it's a very symmetrical graph. And there is a vertical line that kind of cuts it right in half and creates mirror images on both sides. This is referred to as the axis of symmetry, which is the vertical line x equals 0, since x is always 0 along that line. And this is the graph of y equals absolute value of x. A very common picture you're going to see in these next few videos. Next, we're going to graph y is equal to the absolute value of x and then minus 4. So when I go to plug in negative 3, the absolute value of negative 3 is 3, but what's 3 minus 4? That's negative 1. The absolute value of negative 2 is 2 minus 4, gives me negative 2. Absolute value of negative 1, which is 1, then subtract 4, gives me negative 3. 0 minus 4 is negative 4. Then we're back to 1 minus 4, 2 minus 4, and then 3 minus 4. Now when I go to graph these points, I have a point at negative 3, negative 1, negative 2, negative 2, negative 1, negative 3, 0, negative 4, 1, negative 3, 2, negative 2, and finally 3, negative 1. And it looks like my graph has shifted. This is a translation I brought up in the title of the video. Our graph has slid down from what it originally looked like. Since the only thing I changed from the original equation was just subtracting 4, you can see how it's now shifted down 4 units. But even though this graph has shifted down 4 units, it still has a vertex, which is now at 0, negative 4, and it also still has an axis of symmetry, which from this point forward on the graph, I shall just write a lowercase o s for axis of symmetry. But that's still at x equals 0. So that didn't shift, but the vertex did shift downward as well. Now let's look at what happens when we add or subtract the number on the inside of the absolute value bars rather than the outside. Now, when I do negative 3, I'll add 1 first and then take the absolute value. So negative 3 plus 1 is negative 2, but the absolute value of negative 2 is positive 2. Negative 2 plus 1 is negative 1, and the absolute value of that would be positive 1. Negative 1 plus 1 gives me 0. Absolute value of that is 0. 0 plus 1 is 1. 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4. And you'll see how all the points have now shifted in a different respect this time. Because now I have negative 3, 2, negative 2, 1, negative 1, 0, 0, 1, 1, 2, 2, 3, and 4, 3. Oh, sorry, 3, 4. So the numbers backwards that time. And now when I connect all the dots, you'll see there's a different transformation of the graph. It didn't go up or down, but in this case it went left from the original picture in the first example. And with that, we also saw a change in where the vertex went as well as the axis of symmetry. The vertex shifted to the left and now is at negative 1, 0. And our axis of symmetry also shifted to the left. It's now no longer along the y-axis, but now it's along another line called x equals negative 1, where x is negative 1 the entire time. And you see how it kind of shifted to the left. So now we can start to describe similar patterns in functions whenever we add a number to it. You'll see here when we add or subtract a number on the outside, we'll notice a vertical translation, meaning if I add k, it should go up k units, or as we saw earlier, when we subtract a number, it'll go down that many units. Now on the inside, when we added something on the inside, for a horizontal translation, you'd think by adding you would go to the right, but in reality, you're actually shifting left when you add a number. While whenever you subtract a number on the inside, it goes to the right. Now we're going to keep h and k positive, just so you can see the plus and negative on those functions. Now let's go ahead and graph these next two absolute value functions. First, by describing the translation, we'll start with the horizontal translation. Since we're adding 2, that means we're going left 2 units. And since we're adding 3, we'll be going up 3 units. So that changes a few things for us, where our vertex would normally be at 0, 0. Now we're going to be going left 2 units and up 3 units to find the new vertex, which will be at negative 2, 3, which is very helpful for graphing. And our axis of symmetry, which normally is at x equals 0, if we shift it to the left 2 units from 0, now puts it right here at x equals negative 2. And when I go to graph, you'll see here there's typically like a slope of 1 as I go up 1 over 1 to create that graph to the right. So the same thing here. And also to the left is like it has a slope of negative 1, meaning up 1, back 1. But using that axis of symmetry to show that these two lines are symmetric of one another. And then I'll draw my lines. And there's your graph, complete with an axis of symmetry as well as a vertex. We do the same thing for the next example. We'll see that we're subtracting 2, which means we're translating to the right this time. Since we're subtracting, we're going to the right 2 units. And we'll be translating up 1 unit. All this means for us is that our vertex now goes right 2 and up 1. Be the start of our vertex, the very bottom of the function. So at 2, 1. And our axis of symmetry also shifts to the right 2. So it'll be at x equals 2. Because now This vertical line is normally at 0, goes right 2. And I can go ahead and graph the function as well using the same rule as earlier. Up 1 over 1 to the right, up 1 over 1 to the right, and up 1 back 1 to the left, up 1 back 1 to the left, and then I'll draw a straight line through those points. There you go. That's how you graph absolute value functions.